Good morning, students. Welcome to Commodore Group of Schools online classes. So in last class we learned the relationship between zeros and the coefficients. So and also we learned the sum of zeros. If the quadratic polynomial is x square plus bx plus c, when a is not equal to 0, then sum of the zeros, that is alpha plus beta, is equal to minus b by a. And also the product of zeros, alpha beta, is equal to c by a. And also we learned that if you know the zeros of the polynomial and if you want to find the quadratic polynomial, then the formula is k into x square minus x into alpha plus beta plus alpha beta. So in last class we have learned the proofs of this and also we have taken some examples also. Now today we are going to learn, if you know the zeros, then how to find the quadratic polynomial. For example, if you take one example, find the quadratic polynomial. Find the quadratic polynomial if the zeros are 2 and minus 1 by 3. 2 and minus 1 by 3. Now what is given here? Here zeros are given. Alpha, beta values are given. Now we have to find here the quadratic polynomial. Quadratic polynomial. Already we learned that if you know the zeros and if you want to find the quadratic polynomial, you know the formula k into x square minus x into alpha plus beta plus alpha beta. Now, first we have to write what is given. Given zeros. So given zeros. So what are the zeros? 2 and minus 1 by 3. So they are the zeros. So if you assume this is alpha and this is beta. So let alpha is equal to 2 and beta is equal to minus 1 by 3. Now we know the zeros. Now we have to find the quadratic polynomial and we know that if alpha and beta are the zeros, if alpha and beta are the zeros, then the quadratic polynomial is, what is that? K into x square minus x into alpha plus beta plus alpha beta. So in this, k into x square minus x into, now what is given? Alpha beta values are given. So just substitute in this. So what will get? 2 plus of minus 1 by 3 plus alpha beta. Alpha beta is nothing but 2 into minus 1 by 3. Minus 1 by 3. So k into x square minus x into, so if you add it, so what will you get? Plus into minus minus, so 2 minus 1 by 3 plus, if you multiply this, plus into minus is minus, so 2 by 3 you get. Then again k into x square minus x into, so for this one if you take LCM is 3. What will you get here? 6 minus 1 with minus 2 by 3. Now again we can write it as, so k into x square minus 6 minus 1 is 5. So 5 by 3 into x you get. So 5 by 3 into x, again minus 2 by 3. 2 by 3. So k into, so for these three terms if we take LCM is 3. Then after that what we have to do? We have to multiply each term with this LCM. Then 3 into x square will get 3x square. Then after that if you multiply 5 by 3 into 3, then 3 gets cancelled. So you will get minus 5x minus 2 by 3 into 3. Again this 3 gets cancelled. So you will get 2. So in place of k we can give different values. So for example if I take k is equal to 3, then what happens? 3 gets cancelled and you will get this polynomial. So if you take k is equal to 3, then the quadratic polynomial is, so 3x square minus 5x minus 2. So like that we have to find the quadratic polynomial if you know the zeros. So here what we did, we have to find the quadratic polynomial if you know the zeros. So if you know the zeros, to find the quadratic polynomial, so this is the formula, that is k into x square minus x into alpha plus beta plus alpha beta. So if you substitute alpha and beta in this, then we will get the quadratic polynomial. Similarly, take another example. For that, they will give sum and product of the zeros. Sum and product of the zeros. That is, we have to find the quadratic polynomial if sum of zeros is -3 and product of zeros is 2. Here they have not given alpha and beta values. They have given sum and product. Sum is nothing but alpha plus beta value is -3. Here product is nothing but, if you take alpha and beta as zeros, then product of zeros is nothing but alpha into beta is 2. So they are here, they have given sum and product. They are not zeros. So how to find if you know sum and product, the quadratic polynomial if you want to find, then again first we have to write given. So what is given there? Sum of zeros. So if you assume, let the zeros be alpha and beta. Let the zeros be alpha and beta. Because it is a quadratic polynomial, we have to get only 2 zeros. So we are assuming one as alpha, another as beta. And if we assume alpha and beta as zeros, then what is given? Its sum is given as -3. Sum is given as -3. That is, so given sum of zeros. Sum of zeros are nothing but alpha plus beta is equal to how much it is? -3. Similarly, again they have given product of zeros. So product of zeros. Product means we have to multiply these two. So alpha into beta, its value is given as 2. So here alpha plus beta and alpha beta are given. Now we have to find the quadratic polynomial. And we know that if alpha and beta are the zeros, then the quadratic polynomial is k into x square minus x into alpha plus beta plus alpha beta. So if alpha comma beta are the zeros, then the quadratic polynomial is, what is that? K into x square minus x into alpha plus beta plus alpha beta. So k into x square minus x into, so alpha plus beta value is given. How much it is? -3. So substitute here. So we'll get -3 plus alpha beta. Alpha beta value is 2. So in place of alpha beta we have to write 2. Then again, if you multiply these two, then we'll get k into x square minus into minus plus, so x into 3, 3x. So plus 3x and then plus 2. So this is the polynomial, that is k into x square plus 3x plus 2. Now in place of k, if I take 1, then we can give different values, but if I take 1, so if k is equal to 1, then what happened? Its value is 1. So 1 into this polynomial, again we will get the same polynomial, that is, then the quadratic polynomial is x square plus 3x plus 2. So that is the quadratic polynomial if you know the sum and product. So if you observe the two examples just now we learned, so in first example they have given alpha values and beta values. Alpha value and beta value is given. Then to find the quadratic polynomial, so first we have to find sum and product. First we have to find alpha plus beta, alpha beta value. Then we have to substitute in the given formula. We have to substitute in the formula. Similarly, in second example, they have given, again here also we have to find the quadratic polynomial only. But what is given? Sum of zeros and product of zeros. That is alpha plus beta value and alpha beta value they have given. So the formula is same. First we have to observe the question. So what is given here? Sum means alpha plus beta value. Product means alpha beta value. In previous example, they have given alpha value and beta value. So that is the difference between the two. And to find the quadratic polynomial, the formula is same for both the questions. Now, in last class, we have learned the relationship between zeros and the coefficients of a quadratic polynomial. Relation between zeros and the coefficients of a quadratic polynomial, that is a sum of zeros is equal to minus b by a and product of zeros is equal to c by a. Now we are going to learn the relationship between zeros and the coefficients. Zeros and the coefficients of a cubic polynomial. Cubic polynomial. Now cubic polynomial. So we know that the general form of cubic polynomial is p of x is equal to, so p of x is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0. And also we know that the number of zeros, it depends on the degree of this polynomial. Here the degree is 3, so we'll get 3 zeros. So if we assume, let the 3 zeros be alpha, beta and gamma are the zeros of the given polynomial p of x. Now if it is a quadratic polynomial, we have taken only 2 zeros, alpha and beta, because if it is a quadratic polynomial, the degree must be 2, so it has only 2 zeros, so we are taking that zeros as alpha and beta. Now it is a cubic polynomial, if the degree is 3, so we have to get 3 zeros, so we are assuming the 3 zeros as alpha, beta and gamma. Alpha, beta and gamma. And already we learned that to get the polynomial, first we have to write its factors, and if you multiply the factors, then we will get the quadratic polynomial. So now they are the zeros. First we have to write its factors. So what are the factors for this? Therefore the factors are, what will get the factors? If it is alpha, its factor is x minus alpha. Similarly, if it is the 0 is beta, then its factor is x minus beta. Similarly for this one, x minus gamma. And if you multiply this factor, then you will get the quadratic polynomial. So if you multiply, similarly in last class also we have learned. So for example, if you take any quadratic polynomial, x square minus 12x plus 6. So if you find this factor, so what you get, we can write it as, by splitting out middle term, we can write minus 2x minus 3x plus 6. Now in this 2, if you take x as common, you will get x minus 2. In this 2, if you take minus 3 as common, then again you will get x minus 2. So x minus 2 into x minus 3. Again if you take in this 2, x minus 2 as common. So if we equate this polynomial, these factors to 0, then we will get the zeros. X is equal to 3 and x is equal to 2. So how we are getting, so if you find if you equate the polynomials or factors to 0, then we will get the zeros. Now if you observe here alpha, beta, gamma, they are the zeros. First we have to write its factors, so we are writing x minus alpha, x minus beta and x minus gamma. And if you multiply these two, then we will get the polynomial. And also if you observe, we can write 1 as a constant for the multiple of this. So if you take 1 into x minus 2 to x minus 3, then also we will get the same factors only. So if I take 1 means, which is nothing but some constant. It is constant. So similarly, if you take x minus alpha, x minus beta and x minus gamma is there. So if you take k as some constant, and if you multiply these 3 factors, then you will get the polynomial. Now multiply it. So k into, so first multiply these 2 factors. So x into x square, again x into beta minus x beta, then after that take this one minus alpha into x minus x alpha, minus into minus plus alpha into beta, alpha beta. Then after that again we are having another factor x minus gamma. Now again k into, if you multiply these 2, then what will you get? X square into x cube, again x square into minus gamma, x square gamma. Similarly, if you take the second term, x beta into x, so you will get x square beta. Then again minus into minus plus x beta into gamma, x beta gamma. If you take the third term and if you multiply with these 2 terms, so minus x alpha into x, so you will get minus x square alpha. Then again minus into minus plus, so x into alpha into gamma, you will get x alpha gamma. Similarly, if you take the third term, so again we have to multiply with these 2. So alpha beta into x, so you will get alpha beta x. Then after that, if you multiply these 2, plus into minus, minus you will get, and again alpha beta into gamma, that is alpha beta gamma you will get. Then again, if you simplify it, so k into x cube, and also if you observe the x square terms, so this is x square term, here it is x square, here it is x square. In these three terms, if you take x square as common, then the remaining is alpha, this is beta, this is gamma. So we can write it as alpha plus beta plus gamma. Similarly, next we have to take the x terms. So this is the x term, this one is x term, and this is x term. So in these three, we can take x as common. So if you take x as common, then the remaining is alpha beta plus beta gamma plus gamma alpha. So if you take x as common, then we'll get these three terms. Similarly, and last one is constant, so we'll get minus alpha into beta into gamma. Now again, here if you multiply with k, then what will you get? K into x cube minus, so here what will you get? X square into k, x square into k into alpha plus beta plus gamma. Similarly, if you multiply with third term, so k into x into alpha beta, beta gamma plus gamma alpha. Similarly, if you multiply with the last term, k into alpha beta gamma. So if you multiply with k, then we'll get this expression. After that, then if you compare this polynomial with the given polynomial, if you compare these two, then what will you get? X cube, its coefficient a, here its coefficient is k. So we have to equate these two. If you compare these two polynomials, then what will you get? So k is equal to a. So x cube terms if we compare, then we'll get k is equal to a. Similarly, x square terms if we compare, then what will you get? b is equal to, so its coefficient is b. So b is equal to k into minus k into alpha plus beta plus gamma. Similarly, if we compare the x coefficients, then here c is there. So what will you get? c is equal to its coefficient is k into alpha beta, beta gamma and gamma alpha. Similarly, if you compare the constants, then b is equal to, here what we are having, minus k alpha beta gamma. So we can write this as, if you write this minus k to left side, then b by minus k will get, which is equal to alpha plus beta plus gamma. Similarly, for this one, if you write k to this side, then c by k is equal to alpha beta gamma plus gamma alpha. Similarly, for this one, if you write k to left side, then d by minus k or d by k, which is equal to alpha beta gamma. And also, here what we got, k is equal to a. So both they are equal. So in place of k, we can write a. So if you substitute here, then minus b by a is equal to alpha plus beta plus gamma. So if you substitute in place of k as a, then c by a is equal to alpha beta gamma and gamma alpha. Similarly, here also if you substitute in place of k as a, then minus d by a is equal to alpha beta gamma. So this is the relation between the zeros. Zeros are nothing but alpha beta gamma. So zeros and b and a, all they are nothing but they are the coefficients. So a, b, c, d, all they are coefficients. So this is the relation between zeros and the coefficients. So alpha plus beta plus gamma is equal to minus b by a. Similarly, here alpha beta plus beta gamma plus gamma alpha is equal to c by a. So this is the second relation. Similarly, alpha beta gamma, so product of zeros is equal to minus d by a. So this is the relation between zeros and the coefficients of a cubic polynomial. So if it is a quadratic polynomial, we got alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. So this is for quadratic polynomial. For cubic polynomial, alpha plus beta plus gamma, sum of zeros is equal to minus b by a, and here product and sum of zeros, alpha beta plus beta gamma plus gamma alpha is equal to c by a. For this one, alpha beta gamma is equal to minus d by a. So they are the relation between zeros and the coefficients of a cubic polynomial. So if you see one example, we have to verify 3 zeros are given, 3 minus 1 and minus 1 by 3. We have to verify that these 3 are the zeros of the given polynomial, and also we have to verify that the relationship between zeros and the coefficient. Just now we learned the relationship between zeros and the coefficients are nothing but we have to find alpha plus beta plus gamma, it is equal to minus b by a. Similarly, second one, alpha beta, beta gamma and gamma alpha, its value is equal to c by a. Then after that, find the third one, the product of zeros, alpha into beta into gamma is equal to minus d by a. So we have to verify this one. So after, first we have to verify these 3 are the zeros of this polynomial, and then we have to find the relationship between these 3. Now first we have to verify means, so what is given? 3 minus 1 and minus 1 by 3, and the polynomial is p of x is equal to 3x cube minus 5x square minus 11x and minus 3. So first write the given polynomial. Given p of x is equal to 3x cube minus 5x square minus 11x minus 3. First we have to compare the given polynomial with the general form. So what is the general form? Ax cube plus bx square plus cx plus d. If you compare with the general form, then what you will get? By comparing with the general form. General form, that is ax cube plus bx square plus cx plus d. If you compare with this general form, then x cube coefficient here a is 3. So what do you get there? A is equal to 3. Then after that, similarly here in place of b we are having minus 5, and then in place of c we are having minus 11. After that, in place of b, which is equal to minus 3. So if you compare these two polynomials, we got a is equal to 3, b value and c value, d value. Then after that, first we have to verify that, we have to show that these 3 are the zeros of this polynomial. And already we learned that if they are the zeros, and if you substitute these values in the given polynomial, then the polynomial it must be equal to 0. Then only we say that they are the zeros of that polynomial. So first we will check it. So if we take the first 0, that is if x is equal to 3, then if you substitute in place of x as 3, then what you will get? P of 3 is equal to, so in place of x we have to write 3, so 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So then again 3 into 3 cube is 27, and then minus 5 into 3 square 9, then after that minus 11 into 3 33 minus 3. So 27 3 is 81 minus 45 minus 33 and 3, that is minus 36. So if you add these two, 45 and 36, so how much you will get? 5 plus 6 is 11, so 4 plus 4 8, so minus 81 you will get. So if you write 81 minus 81, which is equal to, we will get 0. So here if you after substituting this x value, then the given polynomial it becomes 0. So we can conclude that this 3 is the 0 of that polynomial. Similarly, if you substitute second one, that is x is equal to minus 1. So if you take x is equal to minus 1, then what you will get? P of minus 1 is equal to, so in place of x we have to write minus 1. So what you will get? 3 into minus 1 whole cube minus 5 into minus 1 whole square, then minus 11 into minus 1 minus 3. Now if you simplify it, 3 into, the power is odd number, so you get negative value, that is minus 1, and minus 5 into minus 1 whole square, so power is even, so you get positive value, then minus into minus plus, so plus 11 minus 3. So how much you will get? 3 into minus 1 is minus 3, minus 5 plus 11 minus 3. So if we add minus 3 minus 5, minus 8 minus 3 is minus 11. So minus 11 plus 11, which is equal to 0. Again the polynomial becomes 0. So we can conclude that minus 1 is the 0 of that polynomial. Similarly, if we take the third value, that is x is equal to, minus 1 by 3. So if you substitute in place of x as minus 1 by 3. So if you take x is equal to minus 1 by 3, then P of minus 1 by 3 is equal to, So in place of x we have to write minus 1 by 3. So 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. So just we are substituting in place of x as minus 1 by 3. Then after that, so 3 into, here negative is the odd number, so you get negative value only. So minus 1 by 3 cube is 27. Then after that, so minus 5 into minus and even number, so it becomes positive. So you get 1 by 9. Minus into minus is plus, so 11 by 3 minus 3. Then again 3 ones, 3 nines. Then what do you get? Minus 1 by 9, minus 5 by 9, plus 11 by 3, minus 3. Minus 3 is nothing but we can write it as minus 3 by 1. So again, if you take it 9 as LCM, then what do you get? So if you multiply with this LCM throughout this, each term, so 9 gets cancelled, we will get minus 1. Similarly, if you multiply these two terms, 9 gets cancelled, so you will get minus 5. Here, 3 3s, 3 11s, so you get 33. Then after that, minus, if you multiply these two, 9 3 is 27. So finally what do you get? Minus 27, minus 1, minus 28, and then minus 5. So totally you get minus 33. And here plus 33 is there. So divided by 9, which is equal to 0 by 9. 0 by 9 is nothing but again we get 0. So after substituting these three values, that is if you take x is equal to 3 and x is equal to minus 1 and x is equal to minus 1 by 3. So the polynomial will become 0. So we can conclude that these three are the zeros of the given polynomial. Then again we have to find, so first question is completed, that is we have verified that these three are the zeros of this polynomial. Then after that again we have to find the relationship between zeros and the coefficients. Zeros and coefficients, so which is nothing but alpha plus beta plus gamma its value, and alpha beta plus gamma alpha is equal to c by a. So that we have to verify. Now first we have to comparing. So what we get? So a is equal to 3 and b is equal to minus 5, c is equal to minus 11 and d is equal to minus 3. So if you comparing with the general form, so we got a is equal to 3, b is equal to minus 5, and c is equal to minus 11 and d is equal to minus 3. Now we have to find the second one, that is we have to find the relations. In that, the first one is sum of zeros, alpha plus beta plus gamma is value. So alpha here we have to take this as alpha and this as beta and this as gamma. So they are the zeros. So we are considering the first one as alpha, second one as beta, and third one as gamma. So if you add all these three, so 3 plus minus 1 plus minus 1 by 3. So what do you get? 3 plus into minus minus 1 again plus into minus, so minus 1 by 3. 3 minus 1 is 2. So 2 minus 1 by 3. 2 minus 1 by 3. If you take LCM, so LCM is 3, then we'll get 6 minus 1, which is equal to 5 by 3. Which is equal to 5 by 3. Again, we can write this 5 as minus of minus 5. Both are same only. So if you multiply this again, minus into minus, you will get plus only. So our convenience, so plus 5 we can write it as minus of minus 5 by 3. So again which is equal to, we can write minus 5, which is nothing but b. So in place of minus 5 we can write b, and 3 is nothing but a. Now just we learn that sum of zeros alpha plus beta plus gamma is equal to minus b by a. So it is verified. Similarly, you have to say take the second one, that is alpha beta, beta gamma plus gamma alpha. So this is alpha beta gamma. So if you substitute in this, so alpha into beta, 3 into minus 1 plus beta into gamma, that is minus 1 into minus 1 by 3 plus gamma alpha, that is 3 into minus 1 by 3. 3 into minus 1 by 3. So which is equal to 3 into minus 1 is minus 3. Again minus into minus plus. So you get plus 1 by 3. So 3 gets cancelled. And plus into minus, minus 1. Similarly, minus 3 minus 1 is minus 4. So minus 4 plus 1 by 3. 1 by 3. So if you take LCM for this 2, then LCM is 3. Then again what will get in numerator? So minus 12 plus 1, which is nothing but minus 11 by 3. Again if you observe, minus 11. So minus 11, which is nothing but C. Its value is C. So in place of minus 11, we can write C, and then in place of 3, we can write A. So just now we learned, so product and sum of zeros, alpha beta plus beta gamma plus gamma alpha, its value is C by A. So second one, already verified. Now see the third one. What is that? The product of zeros. So alpha into beta into gamma is equal to, so we have to multiply all these three zeros. So what will you get there? 3 into minus 1 into minus 1 by 3. So if you multiply these 3, then what will you get? Minus into minus plus. So 3 into 1, 3. Again 1 into 3. So 3 into 1, again we will get 3. So we can write it as 3 by 3. 3 by 3. Now again, this plus 3 is there. So our convenience we can write it as minus of minus 3 by 3. So both are same. Minus into minus, again we will get plus only. So minus of minus 3 by 3, we can write it as minus of minus 3. Minus 3 is nothing but, which is nothing but D value. So D is equal to minus 3. So minus D by 3 is nothing but A. So minus D by A. So like that, we can verify the product of zeros is also minus D by A. So the second question is, we have to verify that we have to find the relationship between zeros and the coefficients. In that first one, alpha plus beta plus gamma we got minus B by A. Similarly, product and sum of zeros, that is alpha beta plus beta gamma plus gamma alpha is equal to C by A. And third one, alpha beta gamma is equal to minus D by A.